will transform the most dramatically the next 5 years? What's in your list?
Well, they're also exciting, and that's why, I mean, that for me has been my main passion and always the reason why I've worked on AI for my whole career for 30 plus years now, is to use AI as the ultimate tool. I always thought AI would be the ultimate tool for science and to advance scientific understanding, scientific discovery, and things like medicine, and just our understanding of the universe around us. So actually, when you mentioned our original way we used to articulate our mission statement, which is still the way we think about it, is there was two steps to it. Step one was solve intelligence, i.e. build AGI, and then step two was use it to solve everything else. We had to change that a bit over time because people were like, do you really mean solve everything else? And we did mean that. And I think people are sort of understanding what that means today. But specifically, I was meaning solve other, what I call root node problems in science. So areas of science that would unlock whole new branches or avenues of discovery. And AlphaFold is the prototypical example of what we want to do. So over 3 million researchers around the world, pretty much every biology researcher in the world uses AlphaFold now. And I was told by some of my, pharma executive friends that, almost every drug discovered from now on will have used AlphaFold at some point in the drug discovery process. So that's something we're very proud of, and it's the sort of impact that we hope to have with AI. But I do think it's just the beginning. I don't really see any area of science or engineering that this won't be able to be helpful with. And the ones you mentioned, I think we're at almost like an AlphaFold 1 moment. So we've got very promising results, but it's not quite solved the grand challenge yet in that domain. But I think we're going to have a lot to talk about in the next couple of years on all those areas you mentioned, materials, which I think is very exciting, all the way to mathematics.
In science, I mean, it feels Promethean. It's like, here is this capability, and
I think so. I mean, of course, along with that, including what the parable of Prometheus, we have to also be careful with how we use that and what we use it for, and also the misuse that can happen with those same tools.
A lot of people in this room are trying to build companies applying AI to science. For them, what's the difference between a startup that actually advances the frontier, in your view, versus one that's just wrapping an API around a foundation model and calling it AI for science?
Well, look, I think there's one of the things I would recommend. I'm trying to think about, and I think you mentioned this to me before. What would I do today myself if I was sitting in your place in Y Combinator, looking at things? One thing you have to do is obviously intercept where the AI tech is going. So that's one hard part of it. But I do think there's huge scope for combining where AI is going with some other deep technology area. I just think that sweet spot is whether it's materials or medicine or other really hard areas of science. I think that those kinds of interdisciplinary teams, especially if it involves the world of atoms as well, there's not going to be a shortcut to that, at least in the foreseeable future. Those are areas that are pretty safe from just getting swarmed by whatever the next update is to the foundation models. So I think if you're looking for things like that, that's one of the more defensible areas, I would say. And I've always loved deep tech, so I'm kind of biased towards deep tech things. I think nothing that's really long lasting and worthwhile is easy. And so I'm always being drawn to deep technologies. Obviously, AI was like that back in 2010 when we started out, right? It was thought to just we know it doesn't work kind of thing is what I was told by investors, and even in academia, it was considered to be a very niche subject that we sort of tried in the 90s and we know doesn't work. But if you have belief and conviction in your idea why it's different this time, or what special combination from your background that you had, ideally you're expert in both those areas, both the machine learning and the other area you're applying it to, or you can create a founding team with that expertise. I think there's huge impact to be made there and huge value to be built there.
That's a really important message. I mean, it's hard, it's easy to forget. Like, basically, once you've done it, you've done it. But before you've done it, people are arrayed against you.
Oh, sure. I mean, no one believes in it, which is why I think you've also got to work in things that you're genuinely passionate about. Like for me, I would have worked on AI no matter what happened. I just decided from a very young age it was the thing that could be the most consequential thing I could think of. It's turned out that way, but it might not. Maybe we would have been 50 years too early. And it was also the most interesting thing I could think of working on. And so I would still be working on AI today, even if we were still, in a little garage somewhere and it still wasn't quite working. I would have still been trying to find, maybe I'd have been back in academia or something, but I would have found some way of continuing to work on it.
So, I mean, AlphaFold was like an example of a spike that you pursued and it worked, what makes the scientific domain ripe for an AlphaFold style breakthrough? And is there a pattern, a certain
Yeah.
objective function? Like
The way I should write this up at some point when I have 5 minutes spare, but the lesson I've learned from all the alpha projects we've done, specifically AlphaGo and AlphaFold, is I think the techniques we have and the problems I like to look for are great in if the situation can be described as massive combinatorial search space. The more massive, the better in some ways. So no brute force or special case algorithm will solve it. And that's true of Go moves and of different configurations of proteins, far more than atoms in the universe, both of those. And then you have a clear objective function. So, you could think of it as minimizing the free energy in the proteins or, winning the game of Go. So you need to specify your objective function clearly so you can hill climb. And then enough data and or a simulator that can generate you lots of in distribution synthetic data. If those things are true, then I think with today's methods, you can go a long way into tackling and finding the kind of needle in the haystack that you need for the solution that you're trying to look for. And I think of just drug discovery, by the way, in the same way, right? There is a compound out there that would solve this disease if one could find it, if one could only find it, right? And that wouldn't have any side effects and so on. And as long as the laws of physics allows it, then the only question is how do you find it in an efficient way, in a tractable way? I think we showed for the first time actually with AlphaGo that these systems could find those kinds of needles in a haystack. In that case, the perfect Go move.
I guess to get a little meta, I mean, we're talking about humans using these methods to create AlphaFold, but then there's a meta level, which is humans using AI to explore the space of possible hypotheses. How close are we to AI systems that can do genuine scientific reasoning, not just pattern matching on data?
I think we're close. We're working on these general systems like we have this system called Co-Scientist, and we have other algorithms like AlphaVolve that can go a little bit beyond what the basic Gemini will do. And obviously all the frontier labs are experimenting in this way. I've yet to see anything so far, and we all tinker with the same things, some maths problems that are a little bit harder than IMO and so on. I haven't seen anything yet that is a true, genuine, massive discovery. That's my personal opinion. I think it's coming. I think it may be related to this thing we discussed about creativity and actually going on beyond the bounds of what's known. So clearly that's just not pattern matching at that point because there is no pattern to match to. And it's a bit more than extrapolation. It's some kind of analogical reasoning. And I don't think these systems have that, or at least we're not using them in the right way to do that. So the way I often say that in science is, can it come up with a hypothesis that's really interesting, not just solve one? When I say just, we're now talking about just like solving the Riemann hypothesis or something. This would be obviously amazing, or one of the Millennium Prize problems, and maybe we're a couple of years out from doing that. But I'd like to solve P equals NP. That's my favorite one. But even harder than that would be to come up with a new set of Millennium Prize problems that were regarded by top mathematicians to be as deep and meaningful and worthy of lifetime of study and effort to solve. I think that's another level harder. And we don't have, I still don't think we know how to do that. I don't think it's magical, though. I do think these systems will eventually be able to do that. Maybe we're missing one or two things. And then the way we would test that is, I sometimes call it my Einstein test, which is, can you train a system with the knowledge of cutoff of 1901, and then will it come up with, what Einstein did in 1905, including special relativity, his annus mirabilis? Can it do that, right? And then I think we could run that test. Maybe we should just run that test and keep seeing if that's possible. And once that is, then I think we're on the verge of these systems being able to invent something new, truly novel.
So last question. For the people who are deeply technical in this room, who want to work on something, even close to the scale that what you've created with, it's one of the largest AI efforts in the world, and you've been a pioneer for all these years. So for that, I think everyone in this room thanks you and the folks at DeepMind very, very deeply from the bottom of our hearts. Thank you. What's the thing that you know now about building at the frontier that you wish you'd known at 25?
I think we covered some of it in terms of actually you work out that going after hard problems and deep problems is no more difficult in some ways than going after a shallower, simpler, more superficial problem. They're just differently difficult. There's different things that are hard about each of those things. But I think given life's very short and you know you only have so much time and energy, you might as well put your life force into something that will really make a difference if you hadn't done it, if you hadn't been there to push it. So I would just think of it through that lens. And then the other thing is if you are